Hello everyone. Today I will be explaining derivatives geometrically for better understanding and intuitive derivativing. And it's featuring 5 beignets and 2 lemon curd tarts. I watched a couple videos on how to how to understand derivatives better by using geometry, and I was thinking I could sum it up and explain to you a couple of the tips and tricks, and one of them that I did myself algebraically. Well, I combined geometry and algebra to I think solve it, but I didn't quite check if I did everything correctly, so I could have coincidentally gotten the right answer. Anyways, that's so you can read it. So we're gonna start with x squared. Is that which on a graph looks a little bit like this. And we can understand the slope of it by taking the slope of the tangent line as it follows here, knowing that at its peak it will be 0, and that as it decreases it's going to be approaching 0, and all of that, because we're mapping the rate of its change. We're mapping these really tiny increases. But to me, that was a little bit too confusing. I didn't quite get it. So this is another way to see what's happening here, because we can see x squared as a square. This is x and this is x. And now we can see d of x as our super duper tiny little change. It's important to keep in mind that this is like 0.0001, you know? Maybe I should move the camera closer. Yeah, I think that's a little bit better. Give me just 1 second. Does that work? Yeah, that works. So, d of x on x squared, which we should all know by now is just 2x, or the derivative of x squared is just 2x to the first power because of the power rule. But another way to see this is that we have this thing here. We have another thing here, which is dx times x, right? We have 2 of those, so we can take that times 2. And we have this thing here, which is dx times dx. But in math, apparently they just call this, we don't care about it because it's a super small fraction times a super small fraction, and it's null. So here we have 2x times dx, and I forgot this part. I forgot how to explain this part, but over here we have d of f. Oh wait, over here we just have d, I think. Yeah, because D is... Is D the whole change? Derivative is mapping the... Well, it doesn't matter, because either way, you can see that the derivative of this is just going to be 2 times these things, which are, in this case, like, I think you're supposed to divide there to get d divided by d of x is just equal to 2x, which is correct. But I don't quite know what d stands for. But you can see how this, like, it makes sense. Anyways, it works. It works for cubes, too. These beignets have chocolate and hazelnut filling, and it kind of tastes like if you fill a donut with Nutella, but they're store-bought and they're pretty stale, so they're not that great. But anyways, as you can see here, when you increase, wait, this is x cubed, and if you just increase every side, by this amount, you get 3 of these big things. I don't know if you see what I'm drawing here. 3 of these big panels. And you get these, like, columns that form in the corners. Here, here, and here. And then you get this one cube that forms in the very corner. Here. And we say that this... Oh. Sorry. It gave me... Never mind. Phone was on low battery. We say that this, just like, we don't care about it. So, here we have, if we have each side of this representing x. Oh. If each side is representing x, then this is just x times times the little dx. But, for these purposes, we're going to say we have x times 3, which is 3x squared. Isn't that crazy? And the derivative of x cubed is equal to 3x squared. Whoa! I think that's so much fun. That's a beignet, by the way. They're actually mini beignets. I don't know where they're from, though. I'm going to explain the one... Not explain the one, but, I'm going to show the one that I tried to do myself, which was taking the derivative of 1 over x. This one's weird. I don't like it. I still don't completely understand it. But here, I should probably start by explaining that the box that 1 over x creates is always going to be equal to 1, because this side is, or as x changes here, what is it? Oh, as x changes here, this height is going to be 1 over x. You know, x times x is just, or 1 over x times x is just equal to 1. And so I posed the question. If we increase this side by dx, then this side has to decrease by, then this side has to decrease by d 1 over x, which is not fun. So that's what we got. And I was thinking, this part here has to be equal to this part here. I was like, okay, d of 1 over x, make sure to remember we're multiplying this by x. I forgot that, and that's why I'm telling you to remember it, is equal to 1 over x multiplied by dx. And so, that's what I did. And so I divided by x on both sides to get d of 1 over x is equal to 1 over x squared dx. And if the derivative of something is the change in the y over the change in the x, I'm pretty sure, it should be d of 1 over x over d of x, I think. And if d of 1 over x is equal to 1 over x squared d of x, and we divide it by d of x, or they just kind of cancel out, we get 1 over x squared, which is like not the right answer because it doesn't have the negative there, but we have to envision it as negative because this amount is just decreasing. So like the value, you get what I mean. Because the value is positive, but it's a positive value going in a negative direction. I hope that helps, but I don't know if it will, because I'm not great at explaining things. If you watched all of this, I will give you one of these stickers. They're cats with sunglasses on them. For watching through all of this. Here. This is my favorite part. I have these lemon curd tarts that I made from scratch. So it's lemon curd in a homemade pie crust with meringue toasted on top. Whoa. I like them, but some other people like them more than me. Because, I don't know, I think that lemon curd is quite tart. I'm not as into tart things as other people. Yeah. Honestly, I made this video more for my own understanding of it than for anybody else's. Claiming for it to be a tutorial is kind of like misleading because I don't have a fundamental understanding of it. But just trying to learn it to an extent that I could explain it to other people has helped me develop, a deeper knowledge on the subject. Also, just doing things in a more fun way makes homework a lot easier to do, Like, why make a boring forum post when you can make a video? Okay. I'm gonna finish my desserts. Thanks.